Hello, I wanted to go over homework 4.3.6 next, and I want to talk about a couple of things. This is our inverse trig homework, and I think a lot of us have probably forgotten some of these things. And so remember, when we're doing this inverse trig, if we have our trig function, and then we have an angle, that's equal to the ratio. And if we have the inverse trig function, the inverse, that's the ratio is equal to the angle. And so it's basically our input switch, our x's and our y's, or whatever we have, our input and our output switch when we go from the function to the inverse. And so if we have y equals sine inverse of x, there's some domain restrictions, or really a range restriction on the inverse. And that range restriction is negative pi over 2. Negative pi over 2 is less than or equal to sine inverse of x is less than or equal to pi over 2. And so this means that our sine inverse is really restricted for the range for there. If we were to, and I'm going to do tangent next, because tangent inverse and sine inverse have the same range restriction, and so they kind of go together. Remember, this would be pi over 2. This would be negative pi over 2. And so tan inverse of x goes from negative pi over 2 to pi over 2. Fairly straightforward. The one that's different is cosine. And so if we're trying to graph y equals cosine inverse of x, there is a range restriction on it. And if you guys remember, we did this, it looks kind of like this. And so that's our range restriction. Remember, that range restriction, that means that we're doing a domain restriction on the parent function, on whatever the original function was. So kind of try and keep that in mind. And so this goes from 0 is less than or equal to cosine inverse of x is less than or equal to pi. And so those are the differences. And I want you guys to kind of try and keep track of these shapes and that's going to help us when we go to our unit circle. Okay. So let's solve some problems. These first problems are really super straightforward. You're just going to your unit circle, and remember, we're trying to find sine inverse of 1/2. What does that evaluate to, or what is that equal to? So I go to my unit circle and I look for where sine is equal to 1/2. Remember, sines are y values. And so what we end up with is sine of pi of 1/2 is pi over 6. We should only have one solution for most of these, or for all of these to start with. We could do the same thing for sine inverse of negative square root of 3 over 2. And remember, it looks like this. And so negative square root of 3 over 2 is about right there. That's negative pi over 3. And so that's enough of that. It's basically the same thing with our cosine functions. We're going to move on to, as we say, the more interesting problems. So let's start with 19. We'll do 19 and 20. I'm going to give myself a little more room, and we'll be good. So these are compositions of functions. And remember, we're going to start with the inside. So we're starting with the function on the inside. And so we need to figure out what cosine, and there's no restriction on our cosine, right? So what we really want to know is cosine of pi over 2. What is that equal to? And so you go to your unit circle, cosine of pi over 2 is equal to 0. So we're looking for sine inverse of 0. And sine inverse of 0 is 0, and that's in radians. Done. We can do 20. First, we need to evaluate sine of pi over 3. And if you guys remember unit circles, sine of pi over 3 is the square root of 3 over 2. So this becomes cosine inverse of square root of 3 over 2. Beautiful. So cosine inverse of negative square root of 3 over 2 is pi over 6. Not too bad. Let's change this. Awfully thick. Okay. We'll move down a little bit. Let's take a look at 21. We'll do one more. 21. Okay. So we need to figure out what cosine of 2 pi over 3 is. And so cosine of 2 pi over 3 is negative 1/2. So this becomes sine inverse of negative 1/2. We go to our unit circle and we're trying to find our y value. And so keep in mind, what is the restriction on sine inverse? So let's think about it. This is the range restriction on sine inverse. So this has to be it has to be down here. So this is equal to pi over 6. And I feel like I should probably talk about this for a minute. So let's go to something. Let's come here. When I say that we are going from here to here, and we end up with a value for a sine, we end up with this negative 1/2, right? And so we're trying to find sine inverse of negative 1/2. Well, here's a sine value of negative 1/2, but remember the distance from here to here is not 11 pi over 6 because we're starting here at negative pi over 2. So this distance is really from here to here. It's not 11 pi over 6. It's negative pi over 6. This is not 7 pi over 4. It's negative pi over 4. So it's negative pi over 4. This is not negative 5 pi, or not 5 pi over 3. It's negative pi over 3. This is not negative 3 pi over 2. It's negative pi over 2. And so we want to keep those things straight when we're working through here. All right. So that's why it's negative pi. That's why it's pi over 6. Negative pi over 6, excuse me. All right, so we'll do a couple more of these, what I like to call more interesting problems. And here we go. So 3 over 11 and 2 over 7 for these two problems, those are not problems that we can just go to our unit circle and look up the solution to. So we're going to have to do some work. And what we're going to have to do is we're going to have to build a triangle. So if we were to build our triangle here, and we're going to call this angle theta. So we know sine is opposite over hypotenuse. So this triangle, when we label this triangle, remember, SOHCAHTOA. So when we label our triangle, we know that this is 3 and this is 11, and we're really trying to find this y value. or I'm sorry, this x value, y value. And so we're going to use Pythagorean theorem, and we know that this x is equal to the square root of 11 squared minus 3 squared. And so x is equal to 121 minus 9 is 112. And we need to simplify this. So it looks like we can pull out a 4, and that's square roots of 7. And so that's our x value. Okay. So we used 3/11 to build this triangle. And so now what we're really looking for is cosine of theta. We're taking the cosine of this triangle that we just built. And we know that cosine is adjacent over hypotenuse. So this would be 4 square roots of 7 over 11. And that's our answer. We're going to do something similar over here. We're going to build this triangle. And so we're going to build our triangle right here. And that's our angle theta. And we know that cosine is adjacent over hypotenuse. So this whole thing becomes 2 over 7. And we're looking for our x value. So this x value is equal to, using the Pythagorean theorem, 49 minus 4. So that is square root of 45, which simplifies. We can pull a 3 out as oh man, that was terrible. Hang on. Let's start all over. That's going to simplify as 3 square roots of 5. So now sine of this angle theta, sine of theta would be 3 square roots of 5 over 7. And that's our final answer. All right. Yeah, we'll do cosine. We'll do this one too. So actually, yeah, this is going to be a good one to do. All right. When we look at this, it's tempted to say that, oh, tangent inverse of 3 is like, I don't know what that is. But remember, it's the same as tangent of 3 divided by 1. So we're going to build our triangle. And we have to remember that tangent is equal to y over x, or opposite over adjacent. And so this is 3 and 1. If we're trying to find the cosine of this angle, theta, we need to figure out what the hypotenuse is. And so h is equal to the square root of 9 plus 1. Well, this was pretty nice. That's the square root of 10. So cosine of theta is equal to, cosine is adjacent 1 over the square root of 10. And we need to rationalize this denominator. So I'm going to multiply top and bottom by the square root of 10 over the square root of 10. And this is equal to the square root of 10 over 10. We're done. Not terrible. So they're starting to get a little more interesting. And I'm going to slide my paper around. We're going to take a stab at 27 and 33. We'll see how we're feeling after that point. So 27, they're giving us this range from -1 to 1. And we know that, again, this x is the same as x over 1. So we have to build our triangle. Sine is, opposite over hypotenuse. And so we're looking for this y value. Maybe I shouldn't have put y there because we've got x's and y's and it's confusing. But we know that, I'll do the work right here. We know that this y value, y, is equal to the square root of 1 squared minus x squared. And I would just write that as 1 minus x squared. The square root of 1 minus x squared. Okay, so now, remember, it's this angle theta, cosine. So cosine of theta, cosine is adjacent over hypotenuse. I would call that the square root of 1 minus x squared. I wouldn't write it over 1. That's kind of redundant. There's no need to.